Kia ora. Hello and welcome to our 5th webinar to date. My name is Claire Barber and I am a Teaching and Learning Specialist with Promethean, Australia and New Zealand. Today our topic is the Digital Technologies Curriculum, focusing on years 5 to 8. Now I'm going to be quite obviously and frequently mentioning the actual Australian Digital Technologies Curriculum, but I want to take a moment to reassure our New Zealand teachers that all of the ideas and examples shown here today are just as relevant to the New Zealand curriculum. I'm also attempting where possible to tie in with the upcoming Science Week themes across ANZ. For New Zealand, the primary Science Week is just around the corner on the 16th to 20th of May and the theme is soil. For Australia, the Science Week is 13th to 21st of August and the theme is drones, droids and robots. Now, both soil and robotics are massive topics. There are so many angles to take with them. We only have a short time today, so please forgive me if I haven't covered something you were hoping for in the topics. With that in mind, let's have a look at our agenda today. Now, in the last webinar, we covered the digital curriculum years 0 to 4, and it was pretty mammoth. I ended up recording 2 sessions because there were so many examples. Today, I've really cut that down. Firstly, because I want to keep the time frame, keep to the time frame for once, but also because although the previous webinar was pitched to the younger year groups, many of the activities I shared in that webinar are actually relevant to today's year bands as well. So if you feel like you're wanting more ideas after today's session, I encourage you to watch the webinar 4 recordings on our YouTube channel. Okay. As I'm sure we're all more than aware, there's a huge buzz globally at the moment around coding. We have all seen the media hype. When should we start teaching kids coding? Why must we teach children coding? The government of deepest, darkest Peru is selling the Paddington Bear marmalade recipe to the highest bidder in order to fund coding lessons. Okay, maybe not the last one, but I'm sure you know what I mean. Certainly the media in Australia made a big deal of coding when the digital curriculum was released. And I come across a lot of teachers in Aussie who are still a little nervous about the coding thing. One thing to remember is that coding is not the only part of the digital technologies curriculum. It is only one strand. There is a lot more to the document than just coding. The digital technologies curriculum is a curriculum that encourages thinking, systems thinking, design thinking, computational thinking. What I've tried to do today is focus on the thinking side, the problem solving and the processes. So the first thing we're going to address is a question I get asked quite often. Will ActivInspire help me teach coding? Or can ActivInspire help me teach coding? And the simple answer to this is yes. The more complicated answer to it is yes, to a degree. There are many different ways you can use ActivInspire software to help you teach coding, just like there are many different ways it can help you teach maths or science or literacy or the arts and so on. To look at this further, let's think about what coding actually is. And this is a quote from a book I shared in the previous webinar called Computer Coding Games for Kids by DK Publishers. I like this definition because it's straightforward. In order for a computer to do something, it needs to have been given a set of instructions that tell it exactly what to do. Now, as a teacher, this screams at me links to instructional texts, procedural texts, algorithms, logical thinking, problem solving, systems and sequences. And certainly all of these things tie in beautifully, because if you don't have those skills, you are going to seriously struggle when you sit down to try and script a code in a software, especially when you're looking beyond software like Scratch or Lego Mindstorm, both of which are fantastic coding softwares, especially when you're starting out, or sorry, for the younger children. So one way that the ActivInspire software can help you teach coding is that it can help you prepare your students for coding or encourage the skill set they require for coding. In the previous webinar, I went into procedural and instructional texts, so I won't be touching on those today. Instead, I'm going to be showing you some of the more advanced features of ActivInspire and how you can use these to encourage the logical thinking, the processes, the algorithms, and the problem-solving side of things. Specifically, what we're going to be looking at today is setting actions or changing properties within the software in order to make things do what you want them to. In other words, we're going to be giving the computer a set of instructions to follow to make something happen or occur. I wouldn't necessarily say it's pure coding, but it definitely is along the lines of coding. We're setting an action to an object, and when we say go, the action happens. So hence my to a degree statement earlier. All right, let's have a look into our first example. Now, I've set this up with the idea that it would be an investigation for the students to solve. So I have gone into my resource browser, and remember, in my shared resources, I have a whole lot of images. So I did a search for robot. Remember to do singular, not plural. So in the bar there, I typed robot, then I can hit the play here or just hit enter, and I've got a whole lot of little characters come up here. Now, some of these characters are actually animations. So when we pull them onto the screen, they're going to play. Don't fall into the trap of thinking, that's cool, I'm going to use that one. They're not objects, and they won't behave in the same way as the plain image, which is what I'm using today. All right? They're cute, but they're not going to do what we want them to do. Now, there is deliberately more than one way to solve this question. I've asked a question that is fairly open-ended or fairly open. I would be encouraging my students to look for as many different solutions as possible. In this instance, I might have the students in pairs or small groups to figure this out. I want a collaborative activity. So that would require that I have the ActivInspire software loaded on several computers in the classroom, or perhaps a trolley of computers, sometimes known as computers on wheel or a cow. Standard licensing allows Inspire to be loaded on 5 computers per Promethean IWB or panel purchased. So this can easily be done. The solutions we're going to look at involve using the property browser and the action browser. So these are parameters that I would actually set or advise my students of. So in the browser area, we've got the property browser here. It's the white page with the corner turned down, and next to it is the action browser, which is the colourful spinning top, red and blue spinning top there. Remember, if your browser is missing, you can bring that back by going View Browsers, or there is a shortcut on your keyboard, Control-B for Windows and Command-B for Mac, and your browser window will show up again. Remember also, you can pin your browser out using the little pin in the corner there so that it's not covering up your page, and also so it's not rolling away. All right. Now, obviously, time is a factor in the classroom, so when doing an investigation like this, I would be giving them clues. Instead of saying, open slather, here's the software, go for it, see how many different ways you can come up with, I would actually say, I want you to use the property browser, and I would like you to use the action browser to come up with your solutions. If there was time, of course, I would open that up and see if they could come up with any other ways in the software to solve the problem, but as time is an issue, I've set some parameters. All right. And you can see at the moment on my page, I have my little robot man here. He moves anywhere on the page. I can click and drag him around the page anywhere at the moment. I also have an X on the page. That's just a piece of text. I typed the letter X. And over here, of course, up the top, there's my question. And there's some key points in here. Let's just highlight them. It needs to be a straight horizontal line. We need to stop at the X. And we're looking at moving the robot or the object on our page. Okay, so those are some things to keep in mind during our investigation. Let's go into the property browser now. You can see I've got some different headings here. So the blue lines here, they're headings, and I can unroll them to reveal various options. There's a big clue here, the heading that says page, all right? Currently, these properties all relate to the actual page itself. Anything I set in here sets to the page or makes changes to the page, not to an object on my page. Keep looking here in the property browser while I click on our little friendly robot here. See the difference? There are heaps more headings here, and I can unroll and have a look at, oops, she says, trying to click on things. Here we go. I can unroll these and see loads of different options available. All of these properties now relate to the object I've selected on my page, or in other words, our robot. Now the students will be having a good look through here and trying to see what properties they might be able to work with to answer the question. Logic would dictate that they are looking for properties about movement. Look, we even highlighted that verb in our question up there, okay? I'm going to cut straight to the chase and tell you we are looking for a restrictor. All right, so here are our restrictors here. Let me just roll that up so there's no confusion. We're looking at restrictors, and we want to restrict the movement of the robot. It needs to move horizontally and it needs to stop at the X. At the moment, we saw it could move freely around the page. And when we look here, can move, oh look, freely, but I have a drop-down arrow. And horizontally is an option. So let me select that. Let's now try moving our little robot, and you'll see that no matter where I'm trying to drag him on the page, he actually only moves in a horizontal line. The problem is that he'll move past the X. So we've done one part of the question, we just need to solve the second part. Now the X on our page is also an object, and I can restrict things to do with the X as well. Let me roll these up so we can just see our restrictors. There we go. And you'll notice the very first restrictor says can block, or in other words, can stop. At the moment it's false. If I change that to say true, now this X should be able to stop or block anything trying to get past it. So let's have a look. Here's our robot rolling along, and oh, look, he can't get past that X. Okay, and it's looking at his arm here. Can't get past there. All right. So problem solved in one method. So let me just reset my page here, and we will have a look at a second method. Now, when we clicked on our robot before and we were looking in the restrictors, you might have noticed under can move, there was an option to move along a path. Now at the moment, there's no path set on my page, or no path there that will help me. So I'm going to go to my shape tool. I'm going to choose the horizontal line because remember we're looking for horizontal movement, and I'm going to draw a line from the X because my pathway might as well stop at the X, because the robot has to stop at the X, and I'm going to draw that all the way back to our robot there. Okay, now I'll select Mr. Robot, and in restrictors, under can move freely, I'm going to choose can move along a path. As soon as I've chosen can move along a path, I can come to the option below which says move on the path, ... I click on the ... and here are the options of the things on the page I could choose to move my robot along. Obviously, we're looking for that blue line there. So I select it, I say OK, and now I should be able to move our friendly little robot only along that line. And he stops where the line stops. Okay? So we have solved the problem in a second way. All right, let's turn the page, because on this page we're actually going to apply some actions to solve the problem. All right, so I'm going to come up to my action browser, the red and blue spinning top, and you can see a list here. It's grayed out at the moment because I haven't selected anything on my page. So what I have to do is choose the object on my page that I'm going to apply an action to, and that will obviously be our robot. As soon as I've done that, I can now scroll up and down, and you can see there are literally dozens and dozens of different actions I could choose. I can come up here and I can cut down the actions to be command actions. I could cut them down to be page actions. Really, we're looking at object actions because here's an object on the page and I want to tell it to do something. All right, and once again, I'm going to jump to cut to the chase and say we want to position this robot incrementally. So I want to change the robot's position on the page little bit by little bit by little bit, which is what that action means. And when I've selected the action in the list, underneath you'll notice I've got some action properties to fill in. I have an X coordinate and a Y coordinate to fill in. Don't worry too much about the target at the moment, we'll come to that later. So logically, if I'm thinking about going in a horizontal line, I will be looking at an X coordinate, because if we think about graphing or X and Y axes, it's the X axis that is the horizontal axis. So I'm going to, by trial and error, very quickly, show you the sorts of things that the kids might be doing. So they might put a measurement in the x-axis. They might say 10. Now this measurement is pixels, okay? And the final step they need to do is to apply those changes. All right, so I will apply the change. I can now click on my robot and you can see he is slowly moving along the page. Now that might be too small a movement, so perhaps I want to now set him to move a greater distance along the axis. And if I select him, let me remove the existing. I'm going to select once more position incrementally, and this time perhaps I'll choose 100. All right, apply changes, and then I'm going to jump my robot along like so. And unfortunately, my robot will once more jump past the X. So I would either have to make my X block, just like we did before. So I would use a combination of actions and properties. So I could make, let's just reset that page actually. I'm going to select my X. I'm going to go to Property Browser, under Restrictors, Can Block, True. There we go. And now I'm going to move my robot, and he can't go any further. Okay, so there I've used actions to move my robot in a horizontal line, and I've used properties to help stop the robot at the X. All right, let's turn to the next page, because here's an extension to that activity. What if I were to change the pathway of that robot into 2 dimensions, if that's the right terminology. So I'm going to be looking at a diagonal line that I want to move the robot on. And if I grab a shape tool here, I'm going to draw the diagonal, make it slightly skinnier. Let's have a look. Pretty much a line like that. We want our robot to be going along and up, and it's pretty much along one box, up one box, along one box, up one box. Okay, so I could then, or the students could, be investigating how far is the distance from, let's say where this wheel is lined up here on the edge of this square, all the way across to the edge here. So how many pixels is it from one end of the square to the other, and how high to jump up one square. And once more, we're going to be using the action browser, position incrementally. We're going to say, well, let's try this. Let's try 10 pixels. I'm not going to do the Y, I'm just going to do the X at the moment. Apply changes. Excuse me, browser window. So I'm trying to see how many jumps across to this line here. 1, 2, 3, 4, 5. So if I wanted to do that in one jump, 10 times 5, 50. So let's undo back to there. Let's remove the existing. Remove existing. And let's change this to say position incrementally, X will be 50. All right, now logic would predict that if the robot goes along 50, it will also go up 50 for it to be one whole square. So I'm going to add in 50 here. Now, there is one small thing to be aware of. I will apply changes, and you would think that the robot's going to go up diagonally. However, oh, he's gone down diagonally. There's one sneaky trick with the Y axis to make him go up. I have to make that a negative. So these are all the things that the kids are actually going to be discovering in the investigation. Apply changes. Okay, let's give that another go. Is our robot now going to go up on the diagonal? Yes. Okay, and once more, we would probably use the cam block on our X to stop him going any further, or what you could do is, let's put him back down here, use a vertical line, like so. Oops, make that a different color, just to show you. And we could make this vertical line block. Okay, so properties, cam block, true, done, and now our little robot should stop when he reaches the orange line. Yep, he can't go past it. Now, if this looks a bit ugly and we want it to look a bit zhuzhier or fancier, what we can do is select that orange line, and whoops, I think we've accidentally selected all of it. We can make it invisible. So I used the translucency slider. It's the button that looks a little bit like a breadfruit, and it makes things more or less invisible, as you can see there. So there you have it. All right, but what if we didn't want to move along a diagonal like this? What if we now said to the students, okay, we're going to move the X, we're going to make it so that our line that we want to move him along goes along 3, up 1, along 3, up 1, along 3, up 1. So we're going to move our X over here. Well, logically, if we think about it, we should multiply our X coordinate by 3 and leave our Y coordinate the same. So if we grab our robot and we go back into the actions and we change the properties to say 150, apply changes. Let's have a look now. Does he move along that line instead? Whoops. Yes, he does. Oops. Except I have to also move that line. Okay, so you can see that you can create a really nice investigative activity where the kids are actually working with elements of coding. They are giving a set of instructions to the computer to follow. And this can lead really nicely into a more gaming kind of activity whereby you create a very simple game like this. So here's our friendly little robot here. And what I've done, instead of setting the action of movement to him, I've set the movement actions to these arrows. And to draw the maze and to draw the arrows, I simply used the shape tool here. There's the arrow tool. I used the line tools to get my lines here, and rectangle tools to get those yellow rectangles. Now I haven't set block to any of the rectangles or anything, so technically at this stage the robot can go through them. That's something you could look into. There are some interesting things that happen with blocking, so that's a whole other investigation. I'm not getting into it today. But if we look backwards at what I did to these, to these arrows, if I select one and I'm in my action browser, whatever I've selected, if it has an action attributed to it, it shows up in the list. And you can see here, it's highlighted here, that position incrementally is the action. And you can see down here that this time, to move left, I've had to do a -50 to jump 1 square. Obviously, I'm not going up or down on a y-axis, so that remains 0. But this time I have a target. So each one of these arrows has the appropriate XY coordinate or measurement to jump that number of pixels, but it also has the same target, and the target is this robot. And to set a target, all I had to do was choose the ... in the target option and choose our friendly robot. All right, so there are all of the things that on the screen that I could make move, but the only thing I want to move is my roll-in robot. Yeah, and oops, cancel. If we look at this one, quite obviously, this time I'm looking at going up, so I'm doing a negative jump on my y-axis and nothing on the x, and it's still talking about the rocking robot. And for the last one, it's just a 50 on the y, nothing on the x, and once again, I chose the robot to move. And so, quite easily, the students can create a little activity where they are making the robot move through the maze to try and get them out. Okay, and not incredibly hard to do. Ta-da! And of course, in the digital technologies curriculum, then comes all of the design for the user interface options. So then you can be looking at color, you can be looking at, well, you know, can I use this on my keyboard? Can I use this on a touch screen? Or yes, you can use it on both. But all of the design elements come into it. I mean, obviously, I've put the grid on there so it was easy for me to see, but if we didn't have the grid, then how would that then look when we're moving our robot? Looks a lot cooler, I must say. All right. Anyway, a good extension. Right. Hopping across the ditch in terms of topic now, let's have a look at one or soil. Weblinks here, incidentally, are just to websites where I've gained some information or vocabulary. There are literally thousands upon thousands of really good websites, New Zealand teachers. Soil was a huge topic and turned out to be quite interesting. I was surprised. Now, very quickly, I'm going to go off on a tangent. When I had a look for a nice background picture, I couldn't find anything. When I did a search for soil, I came up with a few things, but they weren't any good for what I wanted. I wanted a background. Now, I could have probably stretched that out, but it wasn't good enough for what I wanted for a background. So very quickly, I'm going to show you how I set this background. I went to Google. I searched soil in Google Images, but I also went to the little cog up in the right-hand side, the options, and I did an advanced search. And the reason I did an advanced search was because I wanted to filter usage rights, because remember, we should be using things we have copyright or permissions for. So free to use or share, that'll do for now. There we go, and that is in fact the image there. I then downloaded that image and it's sitting on my desktop, which, there we go, Soil 2, I've named it. Okay, and all I did was I right-clicked on my page and I said set background. I chose image because I had an image waiting. I browsed, I found the image on my desktop like so. Oops. I then said open, and then I chose how I wanted that to look. So you can, you have all these options. I like to choose stretch fit. This can look awful sometimes. I'll just choose tiled fit so that you can see apply. It tiles the picture. Okay. Oh, what's happened? It looks dreadful. There we go. Oh, different picture, I think. All right, but you get the idea. Okay. Small tangent, but what I wanted to illustrate here was, if you can't find what you want in Inspire, they give you the tools or the ability to create your own backgrounds or resources or whatever. Okay, moving on. For my purposes, I've chosen to do a completely fictitious experiment growing grass seeds in 3 different types of soil. Now, what I did was looking at the different soils, okay, on this cool map here. I looked up Northland, the region I came from in New Zealand, and I chose 3 soils that were found up there because, you know, logically I could probably go and get my hands on those soils for my class. So we've got granular soil, ultic soil, and brown soil. I'm sorry if I'm not pronouncing that right. Maybe it's Ultic. I'm going to call it ultic. All right. Now here are the results of my experiment. No, there is no insert table feature in ActivInspire like there is in programs like Word. I used the shape tool, so I just chose rectangle. I chose a hollow rectangle, so I chose the X up here in the color palette, and whatever color I chose over here, let's say I'll choose red just to demonstrate, and I drew a rectangle, and then I used my horizontal and vertical lines to fill in the rest of the table. All right. Why would I do this instead of going into Word and then taking a photograph of it? Well, sometimes it's important to demonstrate or teach, dare I say, how to put together a table. It's a skill that students still need to have and understand. Up here I've got a table of the same results that I made in Word. So I could open that, for instance. I could, with my desktop tools from Inspire, so we've done this in many of the webinars to date, I could use my camera tool to take a photo of that table that I've made in Word, or in Excel if I've done it in a spreadsheet, and I could plonk that, onto my flip chart page like so if I wanted to, okay? Why would I not just plug my data straight into an Excel sheet and hit a button and have it graph for me? Well, the answer to that is that I want to be able to graph it with my students. I specifically wanted to construct the data table, draw up the axes of the graph, plot the points of the graph with my students so that we could go through the whole process together. I'm hoping that they would have a better understanding of the data after tabling it and graphing it. That's my theory anyway. Hopefully they'll be better able to understand scales on graphs and reading the data of a graph. So obviously I've chosen to do a line graph because for data such as growth, a line graph is a really good one to use. And I've done a little key down here, so just setting up the page. Incidentally, to get the grid on the background here, all I did was I right-clicked on my page, I went to Grid Designer, I ticked Visible, like so. I made bigger or smaller using the plus or minus, and I changed the colour to the blue there. So we could, I don't know, change it to purple. Might look terrible. Let's have a look. Okay, not much different. Now you do have graphs in your library. So in the shared library you've got a folder, sorry, not graphs, you've got grids in your library, XY lined paper, and you can pull it on. However, when you do pull it on, it's always black and white like so, all right? And I didn't especially want that. Now, I do apologise. When I created this graph or this page, I did it on my Mac side, and I obviously chose a font that my Windows side of my computer doesn't match with. So hence why my 1, 2, 3, 4 weeks are slightly awkward looking there. But we're about to graph the final results. There's some results sitting down here. I'll just pull it up and you can see there's a lovely font that I had chosen. However, it wasn't to be. All right, so to graph my line graph, what I used was the shape tool, and I chose what I call the zigzag tool, or it's called the line chain shape tool in our software. And let's just choose brown because we're doing brown soil. And I click down here on 0 to start, and as you can see, I can now stretch this line anywhere I want. I need it to read 24 for my first week, so I'm going to come across to 1 and up to there, but there's 24, and I click. And now I've anchored a point. And week 2 is 34. Oops, I've put my results in a slightly awkward place. Week 3 is 45, which I think is there. And week 4 is 50. Oops, that one, 50. Now I double click on the last one and it stops the line from swinging off again. All right, so that's how you can create a line graph, obviously, within the software. And that's great because it actually does meet a lot of the learning criteria or learning outcomes of the digital curriculum. However, I want to encourage problem solving. I want to encourage a little bit of thinking outside the square. So I've asked my students to think of a different way to graph the same data, and perhaps they might come up with something like this. This is a 3/4 finished graph. I'm just going to pull up the results here so that we've got them to graph, although once again pretty much exactly the same as what we had. I'll just move this. Now, just to show you, I've already set up over here the name of the soil, and obviously week 1, week 2, week 3, week 4, because we did a 4-week investigation. As I hover over the weeks here, you can see I've already put an action on these bits of text. And when I click on, for instance, week 1 for the Altic or Yaltic soil, my graph grows. What happens when I do week 2? It grows some more. So I'm plotting my graph with bars like so. Let me just undo those. So let's see how we created this. There's quite a lot of thinking involved in this. For a start, I had to come up with a scale that would fit my needs, and pretty much I ran the same investigation as I did with the robots. So thinking back, I wanted to see how many jumps before I could make the top of this square here jump up to here, okay? And it was 10. Was it 10? Let's test it. No, of course it wasn't 10, it was 8. So 8 jumps to get to here if I used 10 pixels. So 8 times 10 is 80. Okay? So over here, if I was to select week 1 over here, which has already got the action set to it, and I click on my action browser, I can look back and see what action has been set. So stretch the top of the shape incrementally. The target was that particular shape there, okay? And I'm not talking about Y, I'm not talking about X. There's nothing horizontal about the movement, it's purely vertical, so I'm only talking about the Y coordinates. It would be 130 because over here, oops, cancel you, because over here, if I was to look, granular week 1 was 13 millimeters, and remember it was 10 jumps, so I'm looking at 130 pixels. All right, so with that in mind, let's finish off this graph. Now, over here, what I have to do first is I have to duplicate enough bars for my week. So at the moment I've got 1 bar. I need 4. So I'll just duplicate 2, 3, 4. Okay. Now I'm going to spread them out a little bit so we can see a little bit better. What I have to do is change the properties or the fill properties of these shapes so that they're all slightly different. I also have to make the solid one top and the most see-through or a different pattern for each of these. Okay, so I've selected the back shape. I've come into my property browser and I'm changing my fill from solid to, let's say, vertical, like so. Okay, then I'm going to choose the next shape and I'm changing that one to be horizontal. And then I'm choosing the next shape and I'm changing that fill tool to be diagonal. All right. And as you can see, as they overlap, we see a more complicated pattern happening. So now I just put them one on top of the other like so. Oops, no, I don't do that quite yet. What I have to do is I have to set their stretchable action. So I'm going to come in and say that on week 1, oh yes, I can do that actually. Beg your pardon, I'll stack them all up. All right, so on week 1, I need to stretch the top of, what shape is it? Oh, it might be the one down here, sorry. That one. And it's week 1 of brown, so 24 will be 240 pixels, apply changes. Week 2 was the diagonal one, stretch top incrementally of, where are you, shapes? What am I doing? They'll be down here. That one. Okay, to be 340. Oops. Apply, because the week 2 was this, and I would set week 3 to be 450, and I would set week 4 to be 500. So just let me get rid of that. I'm not going to go through it because we haven't got time to do all of it, but the final thing I would do would be to actually hide the bars here of the graph so that it looks like the graph is growing out of the axes instead of growing from the shape here. And I can do that by taking an area snapshot of, and I'm being pernickety here, I mean obviously you don't have to do this, this is me just wanting to showcase a few extra little tricks possible with the software. Of course it's decided to make that size awkward for me. There we go. Okay, and I'm going to lock that in place so it doesn't move. And now, if I was to ask my graph to grow, ooh, you see, it's growing. Now, I didn't set those two, so I'll just jump to this one. And it looks pretty cool. And all I've done to build that graph is use the actions of stretching the top of the shape to a particular height. Okay. So once again, just to restate, the purpose of this was to try and get the kids to think a little bit more creatively about how they could graph the same results in a different way. I would be encouraging them to use skills that they have learnt or problem solve to find the skills to graph in a way that they have come up with. All right, let's crack on. Now, I really wanted to go into binary and share ideas on how ActivInspire can be used to help you teach binary, but there isn't going to be enough time to do what I want. So I've decided that I will do a separate webinar on binary at a later date because there's so many different ways Inspire could help you teach that. I've included this page still for a couple of reasons. Number one, I wanted to share with you some of the web links and images that might be useful if you happen to be looking into binary yourself at the moment. If you have no idea what binary is or how it works, watch this video. It's all about using a base to number system. That's what computers use. I'm not going to go any further into it than that, but what I will do is just very quickly, I will play this video and I'm going to pause it just as quickly because what I wanted to draw your attention to is this little sign down here that says YouTube. Now, what we're actually doing here is we're playing a video, but we haven't downloaded the video and embedded the video into the page. What we've done is we're playing the video through an embedded HTML code. And there's a few reasons why you might want to do this, okay? First, let's look at how we would embed such a thing. I need to go out to here and I will go to, whoops, here we go. I'll go to here and say, oh, I wonder what soil YouTube videos there might be. Oh gosh. Here we go. That looks safe. This is where I wish I had not decided on the topic on the spot. All right, so I found the video that I want to use, and I come down underneath the viewing pane on YouTube, and I see where it says share. I click on that, and I now have some options down here. I want the embed option. Now you'll see here a highlighted code. If I click show more, what I can now do is, I can have a look at the size of the video. That means what size frame is that going to create in my flip chart page to play that video in. So let's click on the size here. All right, and it's now changed the code to match that. And what I need to do is copy that code, and all I have to do then is back in Inspire, I go across to my main menu and I say insert, link, I'll come here, insert, link, embedded HTML, and I paste that code in there. All right. You could also change the numbers, so the 853 and the 480, you could change those in the code here as long as you keep the speech marks around them, and that will change the size of the frame as well. There is one very, very, very important step. You need to come across to the HTTPS, and you need to take out the S. If you don't, it will put a frame into your page for you. However, nothing will be there to play. It will be a blank white screen. I don't know the reasons. I don't care about the reasons. What I'm telling you is take off that S and everything will be solved for you. So I click OK, and now in there is my YouTube video waiting to play. Obviously, yes, I'm preempting the question. You would need to have permission from your school to be using YouTube or TeacherTube in order for this to work. Now, some of you might be saying, well, Claire, why would I want to do that? Why would I want to embed the YouTube, the link to YouTube, so that it plays in my flip chart page? Well, perhaps because if you're out on YouTube, there's a lot of other stuff around the screen while you're viewing a video. Now, if you've set the kids off to watch this video as part of their learning and they're watching it straight off YouTube, I know I get distracted by all of these things and I think, oh, I wonder if that's going to give me some information, or oh, that looks quite interesting. And before you know it, half an hour's gone past and I've watched 6 other videos, but I haven't done what I intended to do in the first place. So I cut down the distractions, I cut down the ads, I cut down the clutter, if you will. I'm very specifically giving the students one video to focus on. Another benefit is that, I'm just going to shrink the screen a little bit so that we can see. It's going to cut his face off, but never mind. You'll notice the toolbar underneath here. As the video plays, and I'll just turn him down a bit as we go, I can take little screenshots. Okay, and as we go through, you can see I've been able to take still screenshots of the video as it plays. All right, I can then get rid of the video or the link to the video off my screen. This is the video I was trying to do earlier. And you can see I can have these images left. Should I be doing something like an experiment and looking at the sequencing of events in an experiment, or perhaps a method, and I've snapshotted of the important stages of the method, and now we've got images of those to work with. The final point as to why you might wish to use an embedded HTML code to YouTube or TeacherTube for a video is that it ticks a big copyright box for you. Whilst we've embedded the HTML code, it's a link to YouTube. It's a link to a website. It's not like we have downloaded the actual video and then embedded the video into our flip chart. Number one, it saves us some space because it's just a link. And number two, it's a link to the website. So therefore, I haven't breached any copyright and downloaded something I didn't have access to. I'm just linking to it for viewing, if that makes sense. I don't want to scare you off from using videos. Videos are an amazing, amazing tool for teaching and learning. Just be careful you've got the rights to use the video, is all I'm saying. And when I say video here, I'm talking about an actual video. So I've now moved on from embedding HTML code, which links to YouTube, and I'm talking about videos. So if you want to, you can absolutely embed a video, as I have done here, into your into your Inspire flipchart page. So I've got two different ways that I've embedded an actual video this time. And this is just footage I took myself only yesterday. Laurie and I happened to be at a CBIT conference this week with our distributor, and the stand next to ours is the University of Newcastle Mechanical Engineering Department's robotic experts. They have some amazing soccer playing robots amongst other things, and I had a really good chat with these guys. Small tangent. Their advice to students wanting to get into robotics and software writing: you can never take too many maths or science subjects, especially in high school. Their advice to teachers: teach the kids to think. Give them plenty of open-ended questions. Make them do problem solving. What they are finding at university is the students are coming with an expectation of being spoon-fed. They don't know how to solve problems for themselves. They don't know what to do when there's more than one solution to a problem. Anyway, on this page, we're looking at two different ways the video has been embedded. Over here, I've embedded it as a placeholder, so we can see the images here. And over here, I've embedded it as an image icon. So to embed a video, it starts the same way as embedding HTML. So I'm going to go to Insert, Link, and this time File. I'm going to find a video and say Open. And now I've got the choice of how I want this to be on the page. Placeholder, an action object, an image icon, text. Let's put it on as a line of text just to have a look at that. Okay, and I bet he's come up under there. Yep. Now the good thing about if you've put it on as a line of text, because it's text, you can actually edit that to say something else. Control A. Let's try doing my Mac shortcut. Let's call it more info. And the students can click on that and it will open. The boys doing some coding yesterday. It will open the video in a separate viewing pane, and you'll notice that you've still got that option no matter whether you put it in as a placeholder or whether you put it in as a link, and it's the same is true for this. Okay, you can still snapshot off those other options. So I'll just reset my page here. Now, regardless of how you have chosen to embed your video, whether you've chosen to do it as an image icon or a line of text or as the placeholder, there's something very important to note. Now, normally, I know I'm a stickler for showing you the quickest way to do something. Now, in this instance, the quickest way is not the most sensible way. We've gone the long way here because, oh yes, that is the box I want, because, let's put it as a placeholder, what we're looking at, the important part here is the directory or how we want it to store. Now, if I leave store file externally, that means it's linking to my computer and it's following a pathway to where I have it saved in my documents or on my desktop of my computer. And that's fine if I'm the only person that wants to use this information. But if I have taken the time to create a flip chart or at least a flip chart page for a topic, I'm more than likely going to want to share this with my colleagues. Or perhaps in 3 years' time, when I don't still have the same computer, I might want access to the same videos that I've once used. So if I instead choose to store the file in the flip chart, that means that now that movie or that video is embedded into that flip chart page. It will now move with that flip chart. So if I was to now email this out to all of you, you could open this flip chart and you could play the video yourselves because it's moved with the flip chart. If I did it one of my quickest ways possible, which is simply to, just minimize that, which is simply to drag on to the screen like so. So drag my video in there. Oops. There we go. We'll just pause it. Okay. This is saved as a link to my desktop. If I save my flip chart and I email it out to you and you click on this video, you'll have nothing happen, or you'll get an error message that pops up and says cannot find pathway, because it's searching for my desktop and your computer does not have a link to my desktop. So that choice of going the long way, so main menu, insert, link, oh, come on, insert, link to file, brings up, once we've chosen our file, brings up this box. And this is the important one if you want to actually embed a file so that it moves with your flip chart. Now, embedding versus linking is in the digital technologies curriculum. So you can use Inspire to help show that, probably in a better way than I've done today. It's getting towards the end of the day. Now, what I like about the use of videos, whether it's your own ones or ones from YouTube or TeacherTube, is that they suddenly open up the curriculum of any subject area for you and your students. Suddenly you've got access to information, experiments or discoveries around the world that otherwise they might never have the chance to see or do. For instance, science experiments that are too dangerous to perform in a school lab but are a great learning opportunity can be seen, you know, by this HTML embed, or if you've done the experiment under controlled conditions yourself and recorded it, you can then showcase it to your students. And as I mentioned before, you've got the option to take still shots of it for use in your lessons. Another example, robotics investigations that are simply too expensive for schools to ever carry out, or students who've only ever seen bee-bots or programmable vacuum cleaners can witness experiments like the one here, where some MIT students are trying to replicate the movement of a cheetah through robotics, and they're having to completely redesign the way people have thought about robots having to move. They've come up with a new way of movement, basically. The world is suddenly brought into your classroom. Now, that's it for us today. As always, if there's any further questions or comments, please don't hesitate to contact us. I'm hoping that you learnt something along the way today. Ka kite anō, and I'll see you again next time, everyone. Bye-bye.